Okay, so I was gonna, as I just said, this quiz is 7 questions long, and all but one of them is multiple choice. Number 3 is you have to sketch a graph for the answer. The answer column looks like this. So you have to sketch a graph for number 3. See? One other thing to note about, and I close up on this, I'm hoping talking about it will be enough, but on this graph, they never number the axes, but they always give you the this by this on the bottom, which is x min, x max, y min, y max. So you can figure out how the tick marks are numbered. In this case, it's -4 to 4, -3 to 3, so every tick mark is 1. But they're not always that way, so you want to pay attention to that bottom thing when you go to graphing, make sure you're counting correctly. Anyway. You want to just go over these item for item like we did before? Yeah? Okay. Have that quiz review out. Maybe take some notes on it or whatever as you go along. The very first question says this. The function f, whose graph is shown below, is continuous at which of the following points? And it will give you 5 choices. E is all of these. Just so you know, there's 4 choices, 4 actual points. And E says everyone that you've encountered so far is discontinuous. So the function f, whose graph is shown below, is continuous at which of the following points? And so each one of your choices is a single x value. And I think I gave you some graphs to analyze. If you'll take a look at those, the very first question is on page 24, right? Are you there?
84.
Oh, 84. Oh, yes. It looks like a 2. So you're looking at 11 and 12, and take a look at number 11. Where do you believe that graph is continuous? Well, sorry.
Everywhere.
Well, yeah, hang on a second. Is this graph continuous at -1?
Yes. No.
Yeah.
Yes.
It is. Because endpoints, we consider only that part of it that we can see, and it appears to be continuous. Is the graph continuous at 1.3? It is. Is the graph continuous at 1? No. Just for the sake of review, it is not continuous, but what kind of discontinuity is it?
And the points are that.
What did you say? Removable on what?
A point is.
A point discontinuity. Yeah, you can call it that. It's not called that in most books. Removable is better.
Yeah, come on. I said that one first.
You did. You said it first. It's excellent. Okay.
Oh, so
At 1, there is a removable discontinuity because the limit for both sides is the same, and yet the function value is not. That's the definition of a removable discontinuity. Is it continuous at 2?
Nope.
What kind? Is the function continuous at 3?
No.
No, it isn't. Again, what kind? Is it
Is
continuous at 0?
No.
What kind?
Dumb.
No. Okay. So you guys will do just fine on this. You guys seem to know, at least those of you who responded will do just fine. You girls were just looking on, so hope you understand what we were saying.
Continuous if it's filled in.
Sorry?
Is that what we're going at? It's continuous if it's filled in?
Yes.
Okay.
And if it's discontinuous, there are different kinds. But you don't have to identify those in number 1. But you will. Excuse me, as the quiz goes along. Number 2 says, the function whose graph is shown in question 1, so now we're still referring to the same type of a graph, has a non-removable discontinuity at which of the following points or sets of points? People miss this one all the time. And there is no good reason to miss it. Except, and I'm going to give this one away, so pay attention, except that on the graph, if there is an infinite discontinuity, the author of the test did not put an asymptote there. So people fail to look at it. You don't see one of those in number 11. You also don't see one of those in number 12 or 13. That's probably one of the reasons why I haven't asked you to look at it for a long time. But let me show you what sort of a thing that people miss all the time. You have a graph like this. See the whole thing? You might have a graph that comes up like this. This is at -1. And then right here it continues like that. Has a hole there, continues after that, like that. And then over here on the edge, one that comes down like that. And this might be 1 and 2 and 3, and people miss that 3-1 because there's no asymptote drawn. Watch for it.
Wait.
There is an infinite discontinuity at 3. There is a jump discontinuity at -1, and there's a removable discontinuity at +1.
Why is it non-removable also?
No. Discontinuity is not removable.
Yeah, so that would answer the question too, right?
What?
It's a non-removable discontinuity. But it's asking what's a non-removable.
Oh, I'm just stating that in this graph right here, there are 3 discontinuities. One's removable. The question asks, the function f whose graph is shown in 1, let's pretend it was this one, has a non-removable discontinuity at which of the following points or sets of points? And most people will find this one that says at -1. But it's not. It's at -1 and 3.
Oh, you can put 2,
Okay? People fail to notice the one that doesn't have the asymptote drawn. So be careful with that. Okay, are you ready to move on? Number 3? Number 3 says, sketch a possible graph for a function f that has the stated properties. So this is like that worksheet that I gave you in section 2.2, after 2.2, where you had to do that thing on the back and you had to meet 8 stipulations, 8 facts had to all be represented in the same graph. In this one, there are 4. 4 things that you have to accomplish in the graph. So, I'll give you some samples of the types of things that you have to make happen. Here's one. F of 1 exists. Does that mean there cannot be a discontinuity at 1? No, it doesn't mean that. So don't assume things. Limit as x approaches 1 of f exists. Does that mean there's not a discontinuity at 1, those two together?
No.
But what type does it have to be if there is one? Removable. Very good, folks. Okay. Make sure I got this right. Okay. So that's what we just said. What about f is not continuous at x equals 1. You starting to imagine what this might look like? And the limit as x approaches -2 does not exist. These are the 4 types of things you have to meet. 4 types of things that have to be expressed in your graph. So the 2 important points seem to be at -2 and at 1. How are we going to draw? Do you understand that we're going to have to consider at least 2 of these at a time because they're all happening at 1? Maybe all 3 at once? Can you give me some idea of what's going to happen at 1? And would you like to come up and draw it?
Jump discount.
Anybody want to come up and draw it?
Sure.
Okay.
Yeah,
All I want to know is what's going to happen at 1. See if you can draw the situation that accomplishes all those things that are happening at 1. Don't do the 2 thing. Don't do no. Stay away from -2. Just do the 1.
No.
Oh, yeah.
There you go.
Yeah.
Well, he wasn't done.
No. It was done.
Continuity. I
I was,
Sure, Sam.
He was gone, so I told him.
that's good. There's a lot of ways to draw this situation here. Could have come like this, could have come straight in from either side, whatever. What sort of a thing can you draw now at -2
Oh,
that would accomplish all of that?
what are those things even called? I have no idea what you're even referring
It's
to. Negative
Yes.
infinity.
divided by.
What are those things called?
Yes, those,
Yeah.
those things.
Rational, rational loop.
Would you like to come and draw?
Yes,
Come in, come and draw what you intend.
Yes.
Show me what could happen at -2 to accomplish that. Whoops, sorry, purpose.
Okay,
Talking about vertical asymptote at -2.
yeah, like that,
What?
and then that.
All right.
An asymptote.
Okay, and you don't even have to draw that asymptote.
Pretty
With that-
sure we did the vertical one, that's on that. Yeah.
Okay, it's not,
Just-
not accurate.
Does this meet all 4 stipulations? Okay.
Yeah.
Yeah.
Can anyone think of anything else that you might possibly be able to draw at -2 besides that?
Kind of anything.
You get up here and draw it if you will not give it a shot.
Goes where I am. Draw anything. and then
I'll erase
see
what, and by the way, Axel, that was a perfect way to do it. No problem at all. That would have gotten you full credit. Do something else at -2 that will get you full credit. Good. So this thing's not even defined at -2 at all. It doesn't matter that both of those endpoints have holes. That would be fine. One thing you cannot do, folks, is put any other properties in it that is not stated. So in other words, we could not have done this because something's going on at 0 that's not stated. So it will give you these places where there may or may not be discontinuities, but you may not create others just because you feel like it. It has to be continuous everywhere else. The only things that can be discontinuous are the ones that are stated. Okay?
That looks weird.
It does, but it meets it. You just can't make other discontinuities because you feel like it. It can only be discontinuous at the places that this says there should be discontinuities.
When
Yes.
I tried to draw my name.
Yes. Then it would be a non-function and you'd miss the whole thing.
What if I turn my name sideways?
No.
Is there any like function that would actually do that? Like, or a
Wise, a piecewise possibly.
Oh, yeah.
Yeah. You could always design a piecewise to make this happen.
okay.
But no number with no.
Yeah, there's no polynomial or rational function or absolute value function or anything like that I know of that would do this.
Okay.
No,
That'd be cool.
gotta be a piecewise.
That would be
Yeah. No, it wouldn't.
How would you
need
get
to study that.
Big in
Okay, so pay attention to where the tick marks are and try to make things happen really close to where they should. This would be typical example of number 3. Okay, number 4. Number 4 says this. Find the average rate of change of the function, and it's a polynomial function, over this interval. And the interval is, you gotta understand the interval is an x interval. You've done ones like this. So if you look at your review and go to places I asked you to look, that's page 92, numbers 1 and 2. If you've done your homework, you should remember having done those.
Well, not two, but.
Right, not it. Do you recall how to handle them? What's the first thing you have to do? To find the y value so that you have now how many points? 2, and then you find the slope between them. People miss this problem all the time because they fail to pay attention to signs. The author anticipates your failure to pay attention to signs and you end up choosing the wrong one. So please, folks, I hope you learned your lesson. Show your work so that I can see what you intended in case it doesn't turn out that way. I can see what your intention was and give you credit for knowing what to do even though you didn't follow through. All right. Everybody done with number 4? Can y'all handle that? Number 5. Number 5 says, find the slope of the curve at a particular x value. And the curve is a polynomial again. Find the slope of the curve at x equals 4. And the curve is a polynomial. And I'll even give you an example of the type of polynomial you're going to be dealing with, because people, again, for some reason, because you guys are still rusty at your algebra, missed this. I don't know why. This one's not that hard. So if I gave you a function like this, y equals 2x squared plus x. And I'll go ahead and add on 1 back here just for fun. And I want you to find the slope at x equals 4. Supposed to find the slope of that curve when x equals 4.
Difference of the quotient formula.
The HC.
So the limit of the difference quotient.
Limit of the difference quotient. Yeah, that's what I said.
Because we're looking for slope, we'll use the slope formula, the only one we know at this point in calculus, which is the limit as what?
X
H. Approaches 0 of
2 parentheses x plus h squared plus x plus h plus 1 minus 2x plus x, 2x squared plus x plus 1.
How about if I distribute as I write it? Is that okay? Y'all understand what I did there? I'm going to subtract that function, but I distributed the subtraction as we go so I can save myself a step. Over h. Whew, little tiny h there. Now keep paying attention, because there's something in here where you're going to stumble and people kick themselves when they see it. Yes.
So what's the formula?
F of x plus h means all x's get replaced with x plus h. Minus f of x. Minus f of x is minus all 3 of these terms, so I distributed the negative as I wrote it down.
Okay. Where that middle thing come? X plus h plus 1.
This replaced this x.
Oh, okay, I see.
You do?
Yeah. I
Okay.
see that.
There's just no need for a parenthesis there.
Okay.
There is here. Everybody clear on what I've written based on the difference
That
quotient?
last one is just an x, right?
Yes, because I'm subtracting. This right here is f of x plus h. This here is f of x subtracted, but I've distributed the negative already.
Okay, I see now. Okay, perfect.
We all right?
Yeah.
Okay, so now we got to do the algebra on it. So I get 2, and then x squared plus 2xh plus h squared plus x plus h plus 1 minus 2x squared minus x minus 1. Continuing in the numerator, 2x squared plus 4xh plus 2h squared plus x plus h plus 1 minus 2x squared minus x minus 1. Woo.
Okay.
The algebra is not hard, just keep track of everything. The 2x squareds add out, as we've learned to expect with polynomials. The x's add out, as we've learned to expect, and the 1's add out.
Everything becomes so much easier.
So this is what we have now. We have 4xh plus 2h squared plus h left, yeah?
All over it.
All over h. Now here's where people get hung. Pay attention here, because this doesn't show up very often. When you divide the h out of there, you get 4x. When you divide an h out of there, you get plus 2h. When you divide the h out of there, you get plus 1, not nothing. H over h is 1, and people fail to remember, in this situation, they forget that 1,
How do they do that?
and that'll hang you. And the author anticipates that, and it will be one of your choices when you have forgotten that. Y'all gonna watch out for that?
Yep.
Be careful. When you divide by h everywhere, don't do it haphazardly. Pay attention to every term and what's left. Now we take the limit as h goes to 0, and we end up with the slope generator, 4x plus 1. And so the answer is 17 when we evaluate it at 4, not 16. And that has been, the 16 was anticipated by the author, so don't choose badly. It's 17.
Formula is just to get the slope generator and they
Yes,
plug it.
yeah, and that's what I always do. That's what I wish you would do, because this can be useful for making many plugins. You can find the slope of that curve anywhere now. So I like a slope generator and then plug specific values in, rather than run this whole thing through for one specific value. I don't like that.
And the slope is the tangent of the point, right?
Yeah, it's for the tangent of this curve when x is 4.
Okay.
It's really, really steep. It's 17.
Thank
But it's not 16. So watch it. Okay.
It's like,
Only 2 more to go. Hang in there. Next one, number 6, talks about an equation for free fall on a different planet. And it gives you that equation. And it's in the form S equals something with a T in it. They're trying to get you acclimated to what you'll see in physics when you take it. Physics, position is always S. I don't know, it has something to do with Latin. But S is position, and so they will offer you the equation for free fall on this planet as something like this. S equals, and this guy, even though he's really faithful to the idea of physics by using an S, he should also be faithful by using a negative, but he doesn't. So we'll say that he uses 5.2 t squared. I don't like that. Should be a negative, but we're gonna go with it, with what he's got, because this is how it's presented on the quiz. Okay, so it says, for example, it says the equation for free fall on Venus, I don't know, is this. Where t is in seconds. Here's what you're to do. Assume a rock is dropped from a 100-foot cliff. Find the speed of the rock when t is 2.8 seconds. Why did they tell you it was a 100-foot cliff?
Because we honestly got 100 minus.
Because why? What?
We have to put 100 minus 5.2 t squared. No, I think. On our homework, we have to do that.
that's to find the distance of where it's at.
This is what you're supposed to do with it. Assume that a rock is dropped from a 100-foot cliff. Find the speed of the rock when t is 2.8 seconds. Why would they tell you it was a 100-foot cliff?
Because maybe it is the ground before then. It might.
It might.
And you'd be a 0.
It might hit the ground at 2.8 seconds if it were a 25-foot cliff. But they're providing you a 100-foot cliff for you to understand that after 2.8 seconds, it's still falling. It's the only reason the 100 foot's in there, is to give your mind an idea that it's got plenty of time to fall. That's the only reason the 100's in it. People think they have to use that 100 someplace, and I don't think they do.
That makes no sense.
So how fast is it going is not a position question. How fast is it going means instantaneous rate of change, which means slow. So we're back in this boat. But the function's not so bad this time. Won't be so involved. So what shall I write?
Wait, speed equals 5.2 t squared?
Yes.
And we're trying to find the speed at,
No. S stands for position.
that's confusing.
I know it, and I'm sorry. V stands for speed in physics. S stands for position.
That's, okay.
I know, I'm trying to get you used to it. I realize it's stupid. I have no control over it. I did not write the books. I did not.
I feel like I'm gonna
Position.
just plug in the 2.8 into that equation.
Don't do it. This is position.
I might.
Okay, well then you'll screw it up. We want velocity, which is the same as speed. We want velocity of this stone at 2.8 seconds. How do I begin?
Put 5.2 and then t plus h squared in parentheses.
Is there something that goes before that?
Yeah, 5.2.
No, this.
Oh, yeah, the limit.
Don't forget the limit.
Why do we have to do the limit?
Because it is the limit that causes you to find the instant rate of change instead of some average.
No.
Yes.
Yeah.
No.
Tell me again.
5.2 and parentheses t plus h squared.
Yeah, but why is it so important to put the limit? Why can't you just do everything without doing the limit?
As long as you bring it back home at the end, I'm fine. But you have to have the limit in there somewhere.
Minus t
It's the whole idea of instantaneous. That's the whole difference between what you've been doing since Algebra 1 and what we're doing now. That's the difference. You got to have it in there. All right.
and then minus t squared.
Okay.
Okay.
Minus what?
T squared. 5.2 t squared. There we go. Got that.
Come on.
Then
F of t plus h, f of t. Yeah.
yeah,
Over.
h.
Now what?
Distribute the
Yeah,
5.2.
distribute it.
No, don't distribute. You can't distribute before you square.
Yeah.
Oh, you guys are killing me. I told
T
you.
squared plus 2t.
We're getting there slowly.
Squared.
Hang on. Making note.
Sam. You're rushing everything.
Now what?
Oh, now it's.
Now we distribute. All over H. That's gone. Put that here, and we have what?
10.4 t,
Plus 5.2 H.
which disappears.
In the limit.
Oh, wait, what?
Now you're jumping in. Oh, you're jumping.
Well, yeah, but you could just forget the limit and just do it.
Don't forget the limiter, or if I have to look at your work and you miss it, if I have to look at your work and there's no limit, you're gonna get it. Because the limit is what distinguishes algebra from calculus.
But if I still get the right answer,
Then I won't be looking at your work.
okay.
That's the risk you take.
I'm gonna,
10.4t is now what? What do you call this thingy?
Slope,
Slope generator. In the context of the problem, what is this? What will this tell us?
your velocity, v equals that.
Yeah, right. Velocity
Oh.
at any particular t.
So then you just put-
So at this particular t, how fast is the thing going?
2.8 times 10.4.
29.12.
I think your calculator did it.
29.12?
Yep.
29.12 what?
Some meters per second.
Is it meters? Is that what it was at 100 meter
Yeah.
and time was measured in seconds, so yes.
What are you 100 meters or 100 feet?
I don't know. If it was feet, then this is feet. Anyway, it'll all be in there. You'll be able to do it, but you should include units. But since it's multiple choice, the units will be included. And wrong answers are not distinguished from right answers by wrong units.
Darn it.
Every view it is in, and you're right, it was feet. Every single answer is offered in feet per second. So that is not a delineator of answers.
Darn it. That would be nice.
Okay, last thing. Last thing, number 7, is a piecewise function. And it says, determine whether the curve has a tangent at a particular value, and if it does, give its slope. So your choices have 4 slopes, and E is the choice, no tangent. Yes.
Which one is this one?
Huh?
Which one is this one in the book?
I don't know. It's 15 and 17, page 92 and 93. If you guys forget about what happened on the review, or you can't remember how to do a particular problem, this little video will be posted since so many people missed it. And you can all get to my YouTube channel, right?
Yeah.
I never thought that I would actually say those words. I never thought I would have my own YouTube
How many
channel.
subscribers do you have?
Huh?
How many subscribers do you have?
Skypers?
Subscribers.
Subscribers. I don't know. I have no idea how to find that out.
Can I figure it out real quick?
No, not till I'm done with this last example. Then you can. That'd be great.
Okay.
I've not figured that out. Or how to look on here to find out. All right, anyway. So it's a piecewise function, and we are trying to decide if, and I'll tell you right now, it's the slope at the breakpoint. It's the slope where the piecewise function goes from one function to the next function. Okay? And that's where you have to, that's the point where you have to decide if it has a slope or not. What if it's discontinuous there? Then you're done. You don't have to do any more. There cannot possibly be a slope at a discontinuity. Not even if it's removable. Okay. So a function must be continuous before you can determine a slope. But for it to have a slope, if it is continuous, for it to have a slope there, the slope has to be the same from the left function to the right function at that point. The slope has to be the same. Because if you have something like this, and it comes in like this, and then immediately takes off like that, there can be no slope here. Because it's like a teeter-totter. Is the slope this line, or is it this line, or is it this line, or is it this line? You can't tell. And so there is no slope there. So what I'm saying is the slope from the left and the slope from the right at this point, not only does it have to be continuous here, the slopes have to be the same for there to be a slope there. Do you understand what we're looking for?
Yes.
So consider this. We'll let f of x be, I'm going to do a couple of these so that you understand what you're looking for. But let's let it be x squared plus 3. And we'll say x less than or equal to 2. And we'll have the other one be two x I'll go ahead and do plus 3 again for x greater than 2. What's the first thing you should check for? Oh, by the way, we want to know, is there a slope at x equals 2? It's this break point. Slope at x equals 2 question. Does the slope exist? And if so, what is it? How do we go about investigating this?
You can draw it.
You could. That is not completely definitive because sometimes if you got a jump discontinuity, it's so tiny you can't see it. What I'm telling you is it has to be continuous before it can be anything else. How do we check continuity?
Let's say equals 2.
I heard it before that.
Plug it in.
Plug it in. Plug 2 in here and plug 2 in here and see if you get the same y value. Because if you do, it's continuous there. Does that make sense?
Yeah.
If they have different y values, all bets are off. So what happens? What is the function's value at x equals 2? What is it in the first one? 7. What is it in the second one? 7. Check. Continuous. Does that mean that there's a slope there?
No.
Not necessarily. So now we have to find the slope of both. Would be really handy to have a slope generator here. But we got to do it for both. So, what is the limit as h approaches 0 of that top function? What do we write?
X plus h squared plus 3 minus x squared plus 2.
I'm going to say minus 3 if that's okay.
Minus 3,
I'm going to distribute it as I go. All over h, and then x squared plus 2xh plus h squared plus 3 minus x squared minus 3. X squares add out, 3's add out, divide by h, we get 2x plus h. And the limit, as h goes to 0, is now plug-inable. That's the slope generator for the top one. How about the bottom one? How are we going to do that one?
2
Hang on. Don't forget your limit. Sam can argue that all the rest of the time, but the rest of you that want to do well in this class, you can include the limit.
K.
The limit. Okay, so now we're on the second piece, so you're going to write what?
2 x plus h squared. No,
Plus
never mind.
minus x.
It's plus 3 first, right?
Yeah.
Minus,
Minus 2x.
good. And that's going to be 2x plus 2h plus 3 minus 2x minus 3. 2x is that out, 3's that out, over h gives me 2.
Is that?
All the time. Isn't that what you expected? It's a line.
Oh, yeah.
So you don't have to do that. If you recognize that's a line, the slope's going to be 2 all the time. So when x is 2, what is the slope of this parabola? When x is 2, what's the slope of this parabola? M at 2 equals 4. M at 2 is always 2. The answer is no. There is no slope.
For 2 letters.
Sorry?
All that work for 2 letters.
Yeah, well, yeah. This work wasn't necessary now that you see that that thing was a line.
Yeah.
This work was, and it wasn't hard. You've done it before. Do you understand what you're up against here? What you have to decide? First, decide if it's continuous. Figure out what the value of f is for this piece of it and this piece of it at 2. And if it's not the same number, you're done. And you write no limit. If they are the same, then you must continue to show that they either have the same slope or don't. This one turned out to still be no slope. Do you follow me?
Yeah.
But if that number had turned out to be the same as that number at 2, then we would say, yes, it has a slope, and that slope is whatever number they shared.
So if it was like x is equal or less than or equal to 1, then you would have a slope? Like, say,
Only if they were continuous there. And I don't think they would be. If this were a 1, if the breakpoint were 1, this would be 4, and this would
so
be
these things can't
5.
ever be continuous.
What? They have to be continuous first.
These things can't ever have like the same slope.
They-
Because one's like a parabola. and
No,
one's
they
the
could.
other.
They could.
They could?
You could have something like this, graphically speaking. It's hard. They're hard to come up with, but graphically speaking, you could have a piece of parabola come down here and stop right there, and then have the line continue there.
They have the same slope at x equals 1.
They would have the same slope where they break from one to the other. That's why you generate a slope. You get a slope generator for this and evaluate it at 2. This particular one just happened to have a line here, so it's always 2. If this slope here had turned out to be 2, when x was 2, if it had turned out that way, then we would say yes, and that slope is 2. Do you understand? It's possible. This one didn't happen to work out that way. It was continuous, but it wasn't. Didn't have the same slope. So it says, just one more time now that you've seen it, it says determine whether the curve y equals f of x has a tangent. Means a tangent line at x equals. If it does, give the slope. So if this had turned out to be 2 and that had turned out to be 2, then you would choose among your 5 choices the number 2. As it is, you would choose E, which is, does not exist. No. E, which is no tangent. Do you understand?
Yeah.
You would have also chosen that if they had turned out not to be continuous at 2, so that none of this was even necessary. You would choose no tangent.
So when in doubt, choose no tangent.
Sure.
Except that the author specifically designs these things to work out quite often,
Very true. Never mind.
but not always. So that's not a really good, yeah. It may be true that most everything that you encounter doesn't. That doesn't mean that the author will choose one of those. So, there's your quiz review down to number 7. Do you think you could be ready to do this Monday?
Oh, yeah. I'm
Okay.
ready to do it right now.
I hope all you watching will be too. We'll see you later. Bye.
Let's see how many subscribers.